Students, last time we have seen the surface roughness measurement, and in which we have seen these texture, primary texture, secondary texture, how we calculate the CLA value, that is the RA value, then the symbols used for the lay structures, and then the testers or the testing or inspection instruments used for surface testing, in which we have seen Tomlinson surface tester, which is a mechanical type of tester. Then we have seen the Talisurf, which is an electrical type of surface testing machine, where we can get a graph depending upon the texture of the surface. Then we have seen the Macquarien, that is just a mechanical type of instrument which is having a tongue, flexible tongue, and which is to be moved on the surface to be tested. And as we change the angle of attack that we have seen last time, then it goes on as we change the angle, the reading goes on increasing, as somewhere you can find the deflection in the dial, where we can get the grade N1, N2, N3 depending on the value of the that surface texture numerical value in microns. So that we have seen last time. Next is the optical flat. Now what is optical flat? It is just a piece of glass, optical flat, optical grade piece of glass, lapped and polished, which is extremely flat, and there we used a monochromatic light. So this optical flat is placed on the surface to be checked or inspected, and the monochromatic light is allowed to fall on that optical flat. And because of that, we can say when the optical flat is placed on another surface, or the surface to be checked or inspected and illuminated with the monochromatic light, the light waves reflect both the bottom surface of the flat and the surface it is resting on. So we can see the waves, we can get the texture of the waves. So this causes a phenomena similar to, as you can see in physics, you might have seen the experiment for interferometry. So same is the case here. So that optical flat is placed on the surface of the workpiece to be checked or to be inspected, and the monochromatic light, single color light, monochromatic light is allowed to fall on that optical flat, and we can see the waveform. So with the reflected waves of that because of the and that waves or that pattern of waves is known as fringes, and that bands can be light or dark. So here we are seeing the spacing between the fringes is smaller, where the gap is changing more rapidly. So these are the here the sample fringes are shown. So this is the optical flat, this is the source of monochromatic light, and it is allowed to fall on this optical flat, which is placed on the surface to be checked, and then we can see the pattern of the fringes. So here if the straight lines are there, horizontal lines, we can see that it is a flat surface. Then A and B, both samples are for flat surface. C is for spherical or concave surface. Then this D is curved more in one direction. So if it is curved in one direction, the pattern will be like this. Then a smooth cylindrical surface, the pattern will be like this. And if it is some valley or some sort of ridge in the middle, the pattern will be like this. So these are the sample patterns of the fringes because of the interference of the light falling on the optical flat. And here we can, from here we can get the idea about this surface, how that surface is. Depending on the pattern of these fringes, we can detect the surface texture. So this is what is optical flat. Next and the last thing what we are going to see is CMM, that is coordinate measuring machine. So as the name indicates, coordinate measuring machine means we can measure almost all the in all the three direction, x, y, z direction. We can move that probe of the machine. So the machine incorporates the basic concept of three coordinate axes, so that precise movement in x, y, z direction is possible. So all the 6 degrees of freedom, 6 degrees of movement, we can move the probe anywhere else on the workpiece. So this CMM is having more four elements, main four elements. One is main structure of that. That structure is a table and the where the probe is hanged. So some frame is there. So depending on what sort of machine you are having, we can have that structure of that. We'll see that types of machines later. Then there is a probing system. Probing system is for checking the various specifications regarding the workpiece. So as we have seen so many things, right from the screw thread measurement, gear measurement, we have seen so many things, surface roughness, all this we can do with the same machine, with the single machine. That is what is CMM. So CMM, with the help of CMM, we can check, not only check, we can inspect, we can get the numerical value of the dimension and the specification directly with the same machine, or the single machine is useful to check in any of the dimension or any of the specification. So probing system is there. Probing means which is finding or which is measuring or inspecting. Then machine control and computer hardware. So computer hardware is, it is equipped with a computer, desktop computer, and we have to it is nothing but a robot. We have to feed a program to that computer, and that way depending on the program, this machine will act likewise. So software for three-dimensional geometric analysis. So these are the four major constituents of this CMM. All this is CMM is equipped with all these four. So CMM is a 3D device. All the three direction we can move the probe, measuring the physical geometrical characteristics of an object. So we can not only test, we can not only inspect, but also we can measure. So this is the use of CMM. So CMM is a sophisticated machine, very precise machine, which is useful in checking the dimensions, inspecting the dimensions, any of the parameter, any of the specification regarding that particular workpiece. We can check, we can inspect, and we can get the numerical value also. So that again done with the help of the programming. So it is nothing but just like a CNC machine, the CMM works. So CMM is a machine which takes reading in 6 degrees of freedom and displays these readings in mathematical form. So CMM is a specialized form of industrial robot. So here it is shown, this is a bridge type CMM machine. There is a bridge where the probing system is hanged, or that probe is hanged, which we can move in all the three directions. And this is the most commonly used CMM machine structure, bridge type. Then the components are main structure, probing system, and the data collection and reduction system. So it is application software, there is a machine controller, and there is a desktop computer which is responsible for collecting the data and analyzing that data and getting the result. So these are some commonly used main structures of the CMM. Here cantilever type, so it is a hanging cantilever to which the probe is hanged. The strength of this machine is less, or we can say the use is very restricted. Bridge type is very commonly used, where we can accommodate so many types of jobs, or large jobs also, big jobs also. This is column type. Then this is gantry frame structure, or we can say crane type. So there is this we can move. So if the job is a bigger one, say in automobile industries, if you want to inspect the car body or a body for a vehicle, four-wheeler, then that time we may use the gantry frame structure. So we can check that car body to the specifications, design specifications, so that we can have in the uh, bigger where we can have the products or the work pieces of the bigger size. Then this is horizontally suspended x-axis carries the bridge, or we can say the horizontal arm is there where we can have the cantilever type. So these are some structures used for CMM, where most commonly used is bridge type. Then this is the probing system here. There are so many different stylus are used, and depending on what sort of work you are having, whether you want to check the internal dimension, whether you want to check the surface diameter, or whether you want to check the surface texture, whether you want to check the tooth profile or tooth thickness. So depending on what type of work you are having, that tool will go and check. So we'll have to set all this in program. So we'll have to feed a program to the machine. So the machine will decide that which tool is to be used for the required work. So as same as CNC machine tool, as you can see, there the tool post is there, and there are so many tools which are used for different type of work. Then the softwares which are used are the CMM, data collection and reduction system. There are three types of softwares we are using here. PC DMIS CMM, we can call it as dimensional measuring interface standard in the world's leading metrology software. So first is PC DMIS Pro. So it is a fully featured metrology software system without CAD capability. So it is a CMM which can check or inspect or give you the numerical value or the measurements regarding all the features of the workpiece. So that is all. So we can set a program, we can install a workpiece, and we can check whatever we want to check of that workpiece. So then it will display the mathematical measurements in the mathematical form on the display screen. Second is PC DMIS CAD. This particular machine, which can be the CAD app capabilities, means it can be interfaced with the design software such as ANSYS or CATIA. So it can form a interface with the design software. So not only we can export or import the design specifications from the CAD, also we can give the some instructions and some measurements from the CMM to the software, and we can alter or improve, or we can make changes in the design. So the 3D modeling softwares can be interfaced with the help of this sort of application software which is used in the CMM. So CMM can be interfaced with the CAD modules or CAD modules. It allows the import and export CAD modules, and it can be possible to develop, test, debug part programs directly on CAD models, compare the measured data directly to the CAD model. So it can form a interface with the design softwares. Third one is the PCDMS CAD++, it is known as. So it is here, in addition to this interface with the CAD softwares, we can scan the objects. So scanning means it is helpful in the reverse engineering also. So if we are having a product, a workpiece or a product, that product we don't have any design for that. So that product from CMM, we can get scanning of that particular product. On the basis of that, we can draw a 3D model of that, and which in turn can be used in the shop floor for the manufacturing of that. So we can go for reverse engineering also with the help of CMM. So here handles typical scanning task. So scanning can be contact type or non-contact type. So it can be the probe can contact the workpiece, or it can be non-contact type, and you can get the actual image or actual dimensions or actual specifications of that workpiece directly on the screen. So we don't have any design, we have workpiece or we have product. So with the help of CMM, we can get the all the specifications and dimensions of that product. We can feed it or we can export it to the some CAD software which is interfaced with the CMM, such as say ANSYS or CATIA, where we can do the 3D modeling of that object, that particular scanning data can be used for 3D modeling, and wherefrom we actually go for the design, and then we can go for the manufacture, and that design also can, or that manufactured product also can be again checked with the CMM, whether it is having certain say irregularities or certain sort of problems in that particular manufactured workpiece or that particular product. So CMM can check that manufactured product also. So this CMM is a most versatile machine where we can find with the help of which we can not only check, inspect the dimensions, the surface textures, or whatever parameters, whatever specifications you want to check, we can check it. We can get the numerical value directly on the screen, and with the application, with the addition of application of some softwares such as scanning or such as interface with the CAD software, we can make it more say usable, where we can use it for design, we can use it for manufacturing. So this CMM is, we can say, sort of a most versatile machine. Now here we can see the measured and constructed features. So if there are 3 holes here, if a cylinder head is there, there are 3 holes, and we want another hole, or we want a circle passing through these 4 holes. So where that circle is passing through, so we can get it. These circles are the measured circle, or we can say the which are already there, and we want a circle passing through the all these 3. So this CMM can do that. CMM can draw a circle passing through all the centers of the circle. So that is known as constructed circle. So if CMM is doing that, that is known as constructed circle. Here we can find a cylinder is there where the pistons are there, 2 pistons are there, a V-type cylinder is there, and we want to know the axis, point of intersection of axis of these pistons. That will be a virtual one, because it is an axis of this piston will be an imaginary line. So both axes where they are intersecting, that we cannot, we do not know where they are intersecting. So that we can find out with the help of CMM. So we will have to give some measured features, measured dimensions to the CMM, and it can find out the axis of this where that will be intersecting the point. So that will be, say, we can say the, it can construct, or it can find out whatever CMM is find out is known as constructed intersection point. So these are the measured feature, means we are giving the data feeding to the CMM, that is the measured features, and it can give you the result in the form of the constructed features. So this is the versatility, or this is the importance of the CMM in the daily working of an industry. So these are the applications we can find out. Metrology, we can we can have linear measurement, measured and constructed features. So measured means whatever we are having in design, we can give that as a input to the CMM machine. It can find out some constructed feature which we do not have in the design. So it can find out that, as we have seen here, the point of intersection of axis of these 2 pistons, it can find out. So linear measurement, then angular measurement, again we can go for measured and constructed features. Then geometrical features we can find out. Profile checking, we can do that with the help of CMM. Then stages of inspection, receiving, material receiving, in process and final. So where again it is useful, we can find the application of CMM everywhere. Receiving of raw material. In process means wherever we are carrying out certain operations, we want to check, we want to inspect, so there also CMM can be used. And after production means if you want to check finally before dispatch, we can use the CMM. Then purpose of inspection is first piece approval. So the whatever it is received or whatever it is manufactured, so it can be in batch or it can be in number of things we have manufactured, and we want to approve that. So we'll check the piece. So whether that first piece, what it is checked with CMM, if it is say to the specification or to the design specification, then we can approve the batch. So first piece approval, we can do that. Process control, obviously. Pre-assembly qualification of the parts. So before going for assembly of the parts, we want to check if it is a very sophisticated type of part which is very having a prime importance in that assembly. We may check it with CMM whether it is meeting to that specifications or not. Then reverse engineering, I already told you that if we don't have design, if we don't have any idea about the specifications, features, but we have a product, so that product, with the help of that product, physical product, with the help of CMM, we can find out the specifications, the dimensions, the design, and then we go for the manufacturing of that. So this type of reverse engineering we can do with the CMM also. Then location of this inspection, CMM can be at standard room, can be at machine shop, because in process inspection can be done within and on site. So wherever we are going out with the work, we can have the CMM. So this is the CMM, that is coordinate measuring machine, very useful and very versatile type of machine, where we can check almost all the features of the workpiece, specifications of the workpiece, and with the help of the CAD softwares, we can use that for the design, for the 3D modeling, and with the help of the scanning feature of CMM, some additions that we have seen the softwares used here. The third one, that is CAD++. With this we can add the scanning feature in CMM also. So this is CMM, and this ends with your syllabus of the production technology. Thank you very much.